Everyone. Today we are going to discuss about the module 2 in the course of design of reinforced concrete structural elements. Before going to discuss about the module 2, just we are going to revise what we learned in the module 1. In the module 1, we are seeing the different method of the design philosophy, example of working stress method, ultimate method and the limit state method. All the three methods we are discussed about the what is the pros and the cons of the each and every methods. So which method as of now what you are using in the as of now in the civil engineering construction, that also be elaborately discussed. Okay. Now then using the working stress method and for limit state method, we have you seen for a design of the single reinforcement beam and a doubly reinforcement both for working stress method as well as the design methods. But finally, we conclude that as of now in the civil engineering construction, mostly predominantly we are using for the limit state method for designing of the beam and columns, staircases, and limits or footing, whatever may be the structural elements. That is only we concluded for the unit 1, module 1. Okay. Now we are going to start up for the module 2. This is designed for using for the limit state method, how we are going to design the flanged beam as well as the shear as well as the and torsion using the limit state method. Okay. So here the module 2 is comprised of the following chapter: analysis and design of the flanged beams, including the T beams as well as the for the L beams. How the behavior of the RC members in the bond as well as the anchorage in our India concrete members, and behavior of the RC beam in a shear, and a combination of the bending, shear, and torsion, how the beams going to behave here in the member. That elaborately we are going to discuss in the module 2. What is the course objective of the module 1? As a learners to understand the T-beam action of the slabs and the design as per the IS 456 code book. Okay. And then learner to understand the what is your fundamental concept is there in bond as well as the anchorage concept. What is the purpose of bond? When it is bond going to happen? If not properly bonded between the concrete as well as the steel, what is going to happen in our concrete structures, and what is the purpose of the anchorage? What is the minimum length is be required for the to design the anchorages as per IS 456. Everything we need to elaborately we are going to discuss about the in your module 2. Then course objective for the 3, the study the shear behavior in the RC beams. So learner to understand the what is meant by diagonal cracking, how the tears will transform the mechanism, and how to design using the shear, how we are going to prevent the failure for the shear. That is we need to discuss. Then student need to understand the torsion and the combined effect of the beams. So that means study the tension torsion in the beams and is a combination with the bending as well as the shear. The final objective of this module is design the RC member, combination of the bending, shear, and torsion. So as of now, we all need to understand that when your structure we are designing, we cannot expect only for only one load. When the axial load going to occur into the beam, whatever we suggest. Definitely, it's possible of the combined load, and including more than the one, maybe axial and shear and the torsion, everything. So inside, we need to design based on the combined loading. So these are the things for objective of the module 2. So what we need to do, develop the strong conceptual understanding and need for the practical skills for a safe and efficient for RC design. So learner to understand this module 2 for we need to give for more practical skills and efficient for RC design in the construction field. Okay. What is the flanged beam? It's a flanged beam is a combination of the slab as well as the rebolts. Okay. Where do we can see this type of the slab normally available? If you see our example in our college, all the buildings is there for the flanged beams eventually. Now we can see for the example of the what we are showing image also be flanged beams, including the slab as well as the beams. Okay. So in a building, slab and the beams were procured together. That is called we can call monolithic constructions. Okay. What is the monolithic construction? Beam as well as the slab and column. Okay. This we are doing for the construction at the same time monolithically. So behavior is not a separate. It's all the behavior should be a same position. So the slab is not a separated. It's a help to the beam to support the beams. Okay. Example, if you take all our main buildings, everything if you designed in for the flanged beams, all the classroom floor slab, okay, slab plus beam below acts as a T-beam. So we can say for it's a the T-beam. Okay. Now here figure you can see or is a flange here we can call it as a slab. A beam we can call it for a web. So two technical we are using here. Slab normally here in the while designing of the T slab we can say for the flange, and second one is a beam we can here going to say for the web. Both the combination we are going to say for the T beam. Okay. What is the second thing? What reality happens when the load acts? Right. So when you're going to load acting on the each and every floor when the UDL, how we going to behavior of the structure for the T-beam? If you consider the individual member, the slab or individual member beam, the behavior of the structure totally different. That we are discussing in the module 1. Now T-beam, including both for the flange as well as the beam, if you applying the load, that behavior is totally different. Okay. So now, as of now, what we is that top portion. The top portion is called the slab. Okay, it is mainly for the compression. Okay, then bottom portion as the beam is be a tension member. When you're going to start using for construction of the deep T-beam, the compressive area should be increased. The top of the slab and flash should be more compressive area will be increased. For that, if you increase the load also, if you increase the load capacity also, it can able to resist more. Now you can see the figure. Okay, when you're applying the load on the top of the floor for the T-beam. Okay, now top of the slab it be totally should be a compressed and bottom layer should be a tension. That is only shown for the figure in the point number 2. Okay, what is the point number C says? Why slab it be helps when you are going to design for the T-beam? The slab increasing the compression area. Now we can know if you design the single beam, the compressive area is less. When you're going to design as a T-beam, the compressive area is be is a more. That means the more area, occupation area, compressive area is more. So what we are going to do, we can able to go for the more load. When compressive area is more, automatically more load can be carried. When you more load carry, as the compressive area increases, so we can able to get the high strength and better performance of the structure. Okay. Now look at the figure. This is the effective flange width. It will be a slab thickness that is called web of the beam. This is the behavior of the T-beam. So some of the picture we have shown, you can see for in the field picture where we can see the flange of the beams. So when you are moving the one place to other places in our floor and corridor and all the classroom, we can able to notify this type of the structure in our college. So interior beam with the slab acting on the as a flange. Now if you go to the inside, if you see the interior beams, okay, all the beams and columns, if your slab is supported on the above the beam, it's behaving as a T-beam. Then edge beam is maybe a L beam or inverted be a L beam also be possible with the slab acting and to be a flange. A typical building floor system, that is only you are going to see how the slab is placed on the above the beam, how the behavior of the T-beam. Okay. So what is the practical insight? When instead of the increasing the beam size, okay, when you are going to design the building structure, okay, in a practical mode of the more multi-story building as an apart, whatever may be, or want to take the more load, what we need to do? We need to increase the more size. When increasing the size of the beams or slab, whatever, the material procurement will also be very high. Instead of that, we can able to design the T-beam. Okay, so we use the slab to share the compression because here, no, when you're using the T-beam, the compression area is more, load carrying capacity also will be more. So it makes the structure be stronger, economical, and also be more efficient. Okay, now here we can see the image, the two comparison without slab for a rectangular beam and with the slab, that is flange and T-beam, we having two different images here. So the first one without slab, what will happen? Anyway, it's a top for the compression zone and bottom will be a tension zone. When you're going to look out into the T-beam, when you construction monolithic construction, the compressive area will be increased. That means compressive zone will be increased. Okay, so what happens when your compressive zone will increase, automatically load carrying capacity also will be increased. So this is a main advantage of the T-beam or the flange beam when compared to the normal beams. Finally, what is that flanged beam which will increase the more compressive area? When you're increasing the more compressive area, it can able to take the more load carrying capacity. It will be more better performance of the entire type of the structure. Okay, so in a flanged beam, we have a classified of the two types. Okay, that we are going to discuss. First one case is neutral axis lie in the flange, and second case is neutral axis not in the flange, it away from the flange. That means neutral axis in the web. Okay, so what is the first of all, what is in the neutral axis? It is a level where the no stresses exist. That means zero stresses. Okay, exit, that line is called for a neutral axis. Okay, from the neutral axis we can take for above the compression, and below the neutral axis to taken for the tension. So now if you see the images, the typical stress distribution diagram in the RC beam. To take the single rectangular beam, if you mark the neutral axis, no stresses. Above the point and below the point, no stresses will come. That is called zero. Okay, this is called the stress distribution diagram. Above the neutral axis, we can take for the compression zone, and below the neutral axis, okay, taken for the tension zone. Okay, so now see, neutral axis is going to lie in the two different places. Neutral axis inside the slab, that means compression in the slab only, is not coming to the flange. So beam behaves like a rectangular beams. Normally beams, how it will behave, same like that only. This T beam also going to behave. When it's going to behave, the neutral axis lies in the flange. It means that is behavior of structure is like a normal beam. Okay, so only compression only will be slab will be act. The beam act as a rectangle. That's only we are going to see in the images. What is the next case is the neutral axis in the web, not in the flange. Okay, now it will be action in the T-beam. Okay, I hope you know understand the difference between two ends, where BF equal to width of the flange and TF equal to thickness of the flange. Now here see the flanges be lies in the web of the structure. Now it should be action is called the full T-beam action. Now what you conclude that based on the neutral axis, we can able to conclude that where the neutral axis behaving, whether it be a flange or the web, based on that we can able to design our structure. Okay, for the beam structure. When neutral axis lies in the only for flange, we can able to design normal T-zone of the beam. But in course of the neutral axis lies in the beam, we need to go for the using our IS4 method. We need to design for as a T beam. Okay. Okay, that is the image shown in the two images. Neutral axis lies in the web and neutral axis lies in the flange. Okay, when it's neutral axis inside the slab, the compression is stayed by slab alone. Okay, then we can go for neutral axis lie in the web. We need to design behave as a normal rectangular beam. If a neutral axis go to the web, okay, then what is going to happen? The slab alone not enough to resist the compressive forces. Okay, that means forces having a more. Our normal slab not alone cannot able to resist the compression. So this compression going to share in the slab also, that full of the web. Okay, full of the T-beam. Now it will be action is called T-beam based on the our neutral axis. Okay, when you see all this structure, when for the all the floor structure or industrial structure or apartment structure, we are going to construct in the monolithic construction. Okay, slab and beam casting together. Then only we are going to act as a T-beam. So second phase, the slab act as in the compression flange. And a typical four diagram you have seen here, a typical four system slab and beam columns are joined together. That is will be there. Okay, the slab flange you need to be increases, the compression capacity will be increased. When you're increasing the compressive capacity, automatically we can give for the more higher load capacity of structure, and performance and strength point of view will be improved. Okay, so next we are going to discuss about the bond and anchorage. As we know what is meant by bond. Okay, bond between the any other two or more than two material, we need to give for more bond. Okay, that is what is the material here. Normally in concrete, one is to be concrete and steel. This two material bonding is important. Okay, the bond should be here, then only we can say will take the more load, strength will be increased, and the performance and durability structure also will be increases. Okay, then what is it defined as a bond? It's a grip between the steel and concrete. That grip, the word is important. So both in steel and concrete should be having a grip. Okay. So bond ensured that force is transferred from the steel to the concrete. If not good bond, the load is not transferred from the steel to the concrete. So we need for good bond between concrete as well as the steel, main because of purpose of to transfer the load from the steel to the concrete. Okay, what will happen if you try to pull a steel from the concrete? It is difficult because of the bond. If you see now the image is seen now concrete and the steel will be there. The steel in outside of projection will be there. If not good bond, what will happen? If I to pull for the steel, automatically will come out. In case of the good bond between the concrete as well as steel, what will happen? The steel won't come out if you give the force pressure. So what is there? The grip between this concrete as well as steel is very important. When a large forces are required to pull out of the bar because of the bond between the steel as well as the concrete. It's a good bond. So we need to, if we want to pull out the steel, we need for large forces required. So it's a bond developed due to the adhesion, it be a friction and a mechanical interior lock, that is a ribs, that is we can forces. Okay. So what happens without the bond? What will happen of the our structure? Now see the image, smooth or smooth bar we are incorporated in the concrete. What will happen? The poor bond will happen because the smooth mild steel bar without grip ribs or bar if not provided, bars will be provided. So if you're using that bar, what will happen? There may be chances this steel will be slide inside the concrete itself. When you are applying the pull up, it will slip. It will be from the concrete. No force will be transferred because the load if you apply, the steel only going to transfer to the load to the concrete structure. If not good bond, automatically the force won't be transferred. The beam will fail even if steel will be a strong. Okay, because load is not transferred to properly. So automatically, if the poor bond, if we are using the smooth steel reinforcement, we are going to failure for bond failure. So failure due to the lack of bond, that we need to avoid it. So what we need to do for that? Why ribs in the steel is required? The ribbed bar is now the fourth point. If you see, there is a ribbed bar. We will get the more friction, more grip will get for concrete as well as the steel. So rib increasing the friction and the mechanical interlock with the concrete. This improve the bond and strength and ensure the proper force via transfer. So this steel reinforcement only having carrying the load carrying capacity, that will be standard will be concrete. That's why we are going a grip for the ribbed bar. You're getting the more friction between the bar. So how bond will work? So we having a mechanism of the behavior. So first one is be adhesion. So when you're using this ribbed bar in the concrete, how is the mechanism going to work? So chemical adhesion between the steel surface and concrete. So already what is the chemical adhesion in the steel that is going to elongate, is going to give more grip into the concrete. So it will develop the friction. Okay, the frictional resistance between the steel and concrete will be developed. So automatically it will be mechanical interlock for the brick. All the ribs, it will be interlocking into the concrete. So ribs resist the slip by providing the mechanical be interlocking. Okay, now these are the mechanism of the behavior of in the bond in the inside the concrete. So finally conclude that the bond is important. Main purpose of the bond is the load is transferred from the steel to the concrete. Okay, so we need to use the ribbed type of the bar. We need to get for the good load carrying capacity. Okay, then what is the important for the anchorage? What is in the anchorage? The steel bars need to properly anchor. We need to place it properly in the concrete so that the developed stress can be transferred to the safely. So the two type of the material is available, only for the concrete and second one is for the steel. Both material going to develop in the different type of the stresses. Okay, the stresses we need to save properly. For that we need to encourage need to properly. Commonly we have using the three different type of the anchoraging systems. One is a straight embankment, one is a L bend and 90-degree hook. These three commonly we are using for the anchorage system. Okay, so where we can able to see this type of the anchorage system. So ribbed bars in a beam reinforcement, we can see for ribbed reinforcement and anchorage with a 90% hook. Also we can able to place in the beam. While development length we can able to see in the providing the slab. Then column bars in the anchor and the foundation, that is will be linking for anchorage. So these are the common practical usages in the anchorages. Okay. So what is the final conclusion for this bond and anchorages? The bond is very, very essential for the force transfer from the steel to the concrete. So without bond, the structure will be a fail. The bond is very, very important because two materials going to live. That's why we say composite materials. Okay, steel and as well as the concrete. Okay, so we cannot use for smooth bar. We need to use for the rib bar. That is will give for more improvement for a bond. So proper anchorage will be ensure the safety of the structure. That is only we are discussing for here the bond as well as the anchorage. So what's the end behavior of the anchorages? What is in the anchorages? It is a mechanism that the loads and steel reinforcement concrete, the forces can be easily, safely can be transferred. Okay. Now see, look at the structure. At a beam, it be end of the beam, and the bars are bent in the hooks. Okay, this hooks is very important to transfer the stresses to the members. Why anchorage will be included? Without anchorages, steel will slide in the concrete. No forces will be transferred to the steel to the concrete, and beam will fail even if steel will be strong also. Okay? So commonly we can able to use for the hook type of the anchorage. The force will be transferred. So bond holds the steel and the concrete will be together. So already we discussed about the working mechanism of the bond, which is steel and concrete. Okay. This is a fifth point. Now we have seen is a development length. As per code, development length notation is giving L into T. Okay, LD. So minimum length needed so that steel can develop the full strength. Okay. Then load also will be transfer force to the concrete. Okay. What are the factors it be affecting in the development? Bar diameter. Okay, diameter of the bar, and the steel strength of the bar, concrete strength, and the bond condition. This will be affecting for our development of the concrete. So by designing all this type of the beam or a slab or a column, we need to give the providing for the minimum length of the length will be near. So adequate and development length is be essential for safe as well as the effective design of the structure. So as per code IS 456 2000 class 26.2.1 is giving you some minimum anchorage length or development is be required for designing of the structure. When you're taking the straight bar, we need to take for whatever length is with, that is called the LD. The tension bar with the hook, okay, hook type of the anchorage bar for 90-degree hook, we can take for the length development into 0.7. The compression in the straight bar 0.24 into LD. The compression bar with 90-degree 0.17 LD. This is described in our ISY course. While designing which type of the bar we are chosen, based on that we can able to calculate and providing for anchorage bar. Okay. So commonly, while the people are designing, some of the mistake will happening in their site. That is only we are mentioned in the images. Cutting bar too short. Okay, and cutting bar should be more long. It will be projected in the outside also. If you're cutting the bar in the too short, so inadequate anchorage, the bars can able to pull out of the structure. So it will be dangerous. Failure will be occur entire of the structure. Okay, so bond it be holds the steel as well as the concrete together, and the anchorage prevent the bar pull out, and it won't come out. I hope you understand what is between bond, what is the purpose of bond, and what is the anchorage of the bond. Now we need to see for behavior of the beam in shear. Okay. What is be shear? The shear tries to cut the beam in diagonally. Okay. One example, when you're taking the on knife, if you're cutting the our bread, we need to cut it the diagonally. So think the cutting of the loaf of the bread at the angle. Okay, that it can be shear. Where diagonal cracks usually it be occur. So in always the shear crack in the diagonal will be occur at the near the support of the section. So what actually happened in a beam, a diagonal crack starting from the near the support. So angle approximately it's be a 45 degree. When you started to apply load on the beam, okay, that shade fair will be occur near the support of the beam. Almost it will be a diagonal. It's approximately 45 degree. Okay. Where is the location of the crack? The start near the support, inclined about the 45 degree towards the Be a point where is the load going to act. So why it is dangerous in a shear failure is if it's sudden failure, it won't give the any warning system. We may fail even before bending failure also. So we can say flexure failure and shear failure. Predominantly, the shear failure is a more dangerous failure. It is called the brittle failure. It won't give for the any warning systems. Okay, small deformation and immediately it will be fail. So more dangerous will be shear failure. Okay, so now see the fourth point is a typical shear cracks of the pattern. Diagonal cracks near the support. So already we discussed the shear crack will be occur in the diagonally nearly 45 degree and support it making towards to the point. That is only image inclined. Okay, so approximately if you measure approximately it will come the 45 degree shear crack inclined at about the 45 degree. So this is the direction of the maximum shear stresses. Why does the shear crack will be formed? Shear stresses acting along the diagonal plane only nearly 45 degree. So when the shear stress exceed the shear strength of the concrete, the crack will form. This is a common phenomena for the shear strength of the concrete. We take the any type of the beam above the neutral axis will be a compression, below the neutral axis will be a tension. When you are applying load, when you stress in shear stress in concrete exceed the shear strength of the concrete, it will be a shear crack will form. That what is our ultimate aim? We need to prevent the shear failure. So we need to provide the proper shear reinforcement to prevent the shear failures. So what are the factors affecting the shear behavior? One will be a concrete strength. That is very important. What is the type of the grade or the strength we are using for strength? And the web, without the web, and effective depth, amount and the detailing of shear reinforcement, load magnitude, and various position. That is everything important for the affecting of the shear behavior. So how to prevent the shear failure? We need to provide a proper shear reinforcement. As per code says, we are having a different type of the reinforcement available to prevent the shear failure. One is for vertical stirrup and second is a diagonal and a bent up bar. So the three are in the shear you can able to resist. Use the shear reinforcement in the form of the stirrups. So stirrups can able to resist in a diagonal tension. So it can able to hold concrete and be together and prevent for sudden failure. So image shows no stirrups intercept and resist the diagonal cracks. What is coming for in the concrete surface? What is the key point we discussed about the shear? So shear tries to cut the beam diagonally. Okay, that we need to understand when compared to the flexure, the shear how it is going to behave in the concrete structure. So diagonal cracks start near the support section, approximately 45 degree. It will start on starting the support section. Its point going to the meet for the point flow. So shear failure will be sudden, will be dangerous. It is called for the brittle failure. So what we need to do, proper design with the shear reinforcement to prevent the shear failures. So main to avoid the shear reinforcement, we need to for good detailing and ensure the safety and ductile performance of the beam, we can able to prevent the shear. Okay. When we are saying three type of the stirrup reinforcement normally used for the beam in the concrete construction. One is be a stirrup, straight stirrups, and second one for the inclined stirrup, and third one for bent up part. The three are the very important for the to resist the shear forces. Okay. What are the stirrups? Stirrups act as like a safety of the ties. Okay, to hold the main reinforcement. It's a grip given to the concrete. Okay, it will be arrest for the shear type of the failure. What do stirrups will do? Now hold the cracks part of the bit together. When the cracks will form, before that, this stirrups are going to be hold. So stirrups tie up the concrete and hold the cracks section. It be together. It won't allow to the again. That means we are going to stitch the cracks using our strips to stop the crack the growth. If the crack is started, that is the growth also, it is going to stop very easily when you are using for the shear reinforcement. They control the width and the growth of the cracks. So when you see the site observation, now you can see for the diagonal cracks will be occur nearly approximately 45 degree nearly from the supporters. So diagonal cracks in the beam are seen in the near the support. So more stirrups near the support. So as of now, we discussed the stirrups. Shear crack will be about the support section. That's why we are going to provide more reinforcement at the support section alone. When coming to the midspan, we no need to provide more reinforcement more closely. because when coming to the midspan, the shear will be a zero, almost will be a zero. So more stirrups are provided near the support because the shear is a maximum here. That only. That's why we are in the figure source. You will come seeing the support section having a more stirrups closely stirrups and supports so midspan. We are reducing the stirrups reduce spacing. So why are the stirrups are important? The shear force is maximally near the support. If you take the bending moment is maximum at midspan, but shear force maximum at the support. So we need to look at into the consideration. The stirrups resist the shear forces to prevent the incline and diagonal cracks from the opening or repeat bending, to increasing the shear strength and prevent the sudden or failure, as they call the brittle failure. To for that purpose, the syrup is important. So without syrup or insufficient of this syrup, what will happen? Diagonal cracks will occur. That will be a more wide. It's a more dangerous. It will going to lead to the failure. So concrete pieces will be separated from the reinforcement because it won't take the much load. Sudden failure may be occur without any warning. It won't give any warning. What we have seen in the earlier different type of the warning systems. Okay, the beam may fail even before bending failure also. If you not provide the without syrup or insufficient syrup, you are providing the beam. It is very, very difficult. A structure may be failed in very, very easy. Okay. Why more syrups are near the support? The shear is maximum only for near the support. The more support syrups will be provided when compared to the midspan. Okay. When you see the shear force diagram, in the midspan, the shear force will be zero. At end of the two direction, no, the shear force will be there. So where the shear force is the maximum, there we need to provide for the most stirrups. Where the shear force is right, there we need to go for the less the stirrups. So here, shear force is higher than near the support only. That's why we are giving the more stirrups in the support section. Concrete cracks in the shear, stirrups prevent the beam from the breaking will be suddenly. That is the only key point we need to understand the purpose of the stirrups. So stirrups acting as the safety of the time. We hold for the crack. The hold the cracks, the parting will be together to stop the growth of the crack, and most near the support we need to provide and prevent the sudden failure or brittle failure. When you're designing the stirrups, we need to properly weaken it. The next one is torsion in the beam. What is the torsion? It will be twisting of the beaming. When it will go into where which type of the structure twisting or torsion will be happen? It will be edge beams. Okay, when you are providing the edge beam, then beam column, like you can say for the cantilever beams, that if you apply the load, that edge will go into the beam file. Then the L-shaped building, and they are having different load. The load is not acting on the CG. Load away from the CG, the twisting and it will be happen. So those type of the building, that beams will be a fail. The beam supporting will be a cantilever. Okay, and there we are having a different combination that will be. A torsion will be occur. What will be a torsion? It will be twisting of the beam due to the uneven or eccentric loading. Uneven of loading. Okay, not imagine properly loading and eccentric loading. So that we can able to expect the torsion will be occur. So twisting the about the from the longitudinal axis, then torsional twisting will be happen. What will happen in a beam if you torsion will happen? No, so diagonal spiral cracks develop due to the combination of shear and bending. Okay, last slide we discussed about the only shear. Now, because of this twisting, torsion will happen. Both the combination of what will happen, shear and bending. Now, if you see the diagram, okay, it will be a shear crack. Now, it will be near the support. It will be inclined direction, will be 45 degree. Okay, so here the combination going to act shear as well as the bending. For that, we need to provide the special reinforcement for that is called the torsional reinforcement. Why we need to provide the closed stirrups to avoid these? The closed stirrup or torsion reinforcement need to provide properly to hold the longitudinal bars. Main purpose is hold the section will be together because it is going to active both type of the stresses, only for shear as well as the bending. And second one will be resisting for the twisting and provide a path of longitudinal will be bars. Okay, then help resist for torsional resistance. So what is the key point of this one? The torsion makes a beam act like a closed tube. Was a box to resting for twisting, because now the unimaginable forces going to act in combination of shear and bending that we need to hold. We need to provide a torsion reinforcement. Okay. What is the conclusion for this torsion? Torsion causes for the twisting in the longitudinal axis. So it will be acting as a diagonal cracks formed due to the shear as well as the bending, combination of the shear as well as the bending. For that, we need to provide the closed stirrups. Okay. So let's hold the section to resist the torsion. So more stirrups near the support where the shear is maximum. Okay. While coming to the mid-span, we need to reduce the stirrups also. So prevent the sudden and brittle failure, we need to provide the proper detailing of the torsion reinforcement. Okay. When you are looking into the combination of the shear, bending and torsion, how the behavior of the structure. Now, when look at in the diagram of the first one, in a real building is a combination of the slab as well as the beam and the column. Okay. So in a beam, if you look at for this type of this structure, we cannot expect only one forces will be acting. It's a practically okay. Force will be acting of the combination. Okay, more than one forces, maybe chances of the bending and shear. And shear as well torsion. Okay. Now here, three type of the forces acting on the real structure. One is a bending, shear, and the torsion also. What's the practical design idea when you're designing of the torsional reinforcement? Then torsion reinforcement in convert to the equivalent bending moment. That equivalent bending moment is we need to see for the equivalent shear, then design the normally. Okay. Here we two type of the design we need to taken into consideration while designing the torsional reinforcement. One is the equivalent bending and equivalent shear. Then we need to go for the normal design while designing of the torsion reinforcement. So this is simplified design using the standard bending and shear and design methods. So when I look at the real type of the bending, here three type of the forces will be acting. Bending will act and shear and torsion, that is will be acted. We taken into account for equivalent bending and equivalent shear, then we need to go for the normal design of the beam. Okay. Okay. Force of the reinforcement, resist the bending moment. When you take the simply supported beam with applied the UDL, it's going to resist the bending moments. So provide the as a main reinforcement bar, top and bottom. In case of single reinforcement providing the tension, bottom only tension zone. With double reinforcement can able to provide the above the neutral axis and below the neutral axis also. Okay. When you're bending of the main bars, top bars we can say for the compression reinforcement. Bottom bar you can care for the tension reinforcement. So top bar resists the compression and the bottom bar resisting for the tension. So when looking at the reinforcement summary in the shear stirrups, resist the shear forces provide as a vertical stirrups. So mainly shear cracks will be occur in the support section approximately 45 degrees. So we need to provide for the shear reinforcement. Then we have torsional reinforcement, like a box, it be closed stirrups to provide for the our structure and longitudinal bars. So it will be resistive for the torsion. So it will provide the closed stirrups plus the longitudinal bar. It will be resist for the torsional movement. When your forces will be acting on the bending and shear are torsional, okay, that is called the combined action. The beam resists the bending, shear, and torsional all together. What we need to do, we need to convert as the equivalent bending moment and equivalent shear. Then we need to go for the normal design of the structure. Okay, the beam is a real structure to resist the bending as well as the shear as well as the torsion. That will be together. All three forces will be. This is a practical. It's a possible. We cannot expect the only one forces will be acting. We can say for all the three forces acting on the together. So as a normally design of a structure, as a civil engineer, we need to do this. We can look at and we need to design for the three type of the forces will be acting on this structure. Okay, so we want to do the proper reinforcement and ensure the strength and stability and safety of the structure. So now we need to understand what is the reinforcement available, which type of the bending and the shear and torsional, how to provide the steel reinforcement in the practical consideration. Okay, so dear learners, hope you understand what you learned here. Okay, this is the outcome you learned. What is the first outcome? You can able to explain the flanged behavior. Now you can able to understand the what is a flanged beam, or I can call this a T beam. You can able to identify the compression flange web and TBBB accent. Then you can able to understand the moment of resistance and the stress distribution of the flanged beams. Okay. Now you can able to explain the what is mean the bond and what is the purpose of bond and it be anchorage. You can able to explain the bond between the steel as well as the concrete. Now you can able to explain, describe the anchorages and the hoops and what is the purpose of the development as per IS 456. You can understand the factors affecting the bond strength. Okay, that everything you can understand for the second outcomes. Now we can able to analyze the beaming, you to know, understand the shear forces and it be a distribution, and study the diagonal tension, shear cracks and failure modes. You can understand the shear resistance and mechanism of the both concrete as well as the steel the structures. Now you can able to evaluate the torsion and the combined loading behavior of the structure. Understand what is in by torsion and purpose of the torsion. When will be torsion will be occur? What are the effect of the torsion? Okay. So what you do when you can able to design now, closed stirrup and longitudinal bars for the torsion, and you can able to evaluate the combined effect of the bending, shear, and the torsion for the concrete to be a structure. Okay. Now you can able to design the RC member to combine the action for the bending, shear, as well as the torsion. Now you can able to whatever learned apply the knowledges of bending, shear, and torsion. You can able to design the RC beams, safety, serviceability, and durability. As what is the IS 456? No, it will be mentioned the guidelines and detail of the reinforcement. As per our code, we can able to understand. You can able to design for. Flanged beams using the under shear and bond and anchorage or torsion reinforcement. When you look at into the starting of the construction, we need to see the further safe. It will be a serviceable, it's a durable, and we need to accomplish. We cannot compromise the code complaint also as well mainly for the IS 456. Okay. So when you're designing the structure, we need to look into the detailing is important. When your detailing is good, we can save for it's a more durable, it's a more serviceable for long. It will be more performance of the structure. Okay, dear learners, again we can able to use our textbook on the design of reinforced concrete structure using latest IS 456 to 2000 and Krishnaraju and concrete design for our Unikishan Pillai and the Avadas Menon of the our concrete structures. So we can use those type of the book, we can able to learn. So thank you for all to listening of our lectures for the module 2 design of the flanged beam as well as the bond anchorages here as well as the for torsion reinforcement. Thank you. Very soon we are going to see for next module very soon. Okay. Thank you. Thank you very much.